According to Richard Feynman, the universe hides a deep mystery, a mystery about time. Everyday life seems obvious. Events move only forward, never backward. A glass falls, it shatters instantly, fragments scatter everywhere. But something strange happens. No one waits for the reverse. No one expects shards to rise. No one sees broken glass rebuild. The cup never returns. According to Feynman, this observation matters. It reveals something about reality, something fundamental. Consider ocean waves. They crash violently. Foam spreads outward. Energy dissolves everywhere. But nobody waits for the reverse. Foam never gathers. Water never rises. Waves never rebuild themselves perfectly. Nature always moves one direction, forward in time, toward disorder. This idea feels obvious, almost too obvious, but Feynman noticed something surprising. When physicists study nature's equations, they discover a strange fact. The laws themselves have no direction. They work both ways, forward in time or backward in time. According to Feynman, this creates confusion because experience says otherwise. Time clearly flows in one direction, but physics disagrees. Consider gravity. Imagine a planet orbiting a star. The motion follows precise equations. Now imagine something. A camera records the entire orbit, a simple film. The planet moves around its star. Now reverse the recording. Play the film backward. Something unexpected appears. Nothing looks wrong. The orbit still works. The planet still moves perfectly. The equations remain valid. Gravity accepts both directions. Forward motion works. Backward motion works. According to Feynman, this pattern repeats. Electric forces behave similarly. Magnetic forces behave similarly. Atomic interactions behave similarly. Even molecular collisions remain reversible. Imagine two molecules. They rush together. They collide suddenly. They bounce apart again. Now reverse the film. The collision still works. The physics still matches. Nothing breaks the laws. Nothing violates nature. Every detail remains correct. This leads to a strange possibility. Imagine something impossible. Imagine every particle in the universe suddenly reversing direction. Every velocity flips. Every motion reverses. According to Feynman, something extraordinary happens. The universe rewinds. Events begin undoing. Broken cups rebuild. Smoke returns to cigarettes. Sound waves reverse. Voices fly backward. Words return into mouths. Footprints disappear slowly. Every event unwinds perfectly because the laws allow this behavior. And yet, it never happens. Not once. Not anywhere. The universe clearly prefers one direction. Forward. Never backward. So Feynman asked a deeper question. Where does this direction come from? To understand this, he proposed a simple experiment. Imagine a container. Inside it, two liquids exist. Clear water fills one side. Blue ink fills the other. A thin divider separates them. Now remove the divider slowly. Immediately, molecules begin moving. Tiny random motions. Invisible collisions. The blue spreads. The water mixes. Soon the container turns light blue, uniform everywhere. This feels natural, completely expected. But now imagine the reverse process. Uniform blue water fills the tank. Suddenly something happens. Molecules begin separating. Blue gathers together. Clear water forms elsewhere. Gradually order returns. Blue on one side, clear on the other. Anyone watching this film would immediately laugh. Something looks wrong. Something impossible. The film must be reversed. Yet here is Feynman's insight. If physicists zoom in close enough, something surprising appears. Every molecular collision still obeys physics. Two molecules approach. They collide gently. They bounce away. Now reverse the film. The collision still works. The motion still follows the same equations. Nothing breaks physics. Nothing violates nature. Yet the overall result looks impossible. Instead of mixing, the liquid separates. Instead of disorder, order appears. According to Feynman, the explanation is simple, but incredibly powerful. It is probability. When billions of molecules move, there are countless ways to mix together, but very few ways to separate perfectly. Mixing is common. Separation is rare, extremely rare. Technically possible, but unbelievably unlikely. The atoms could separate themselves. The laws allow it, but the chances are astronomically small. So small they effectively never happen. This creates an illusion. Nature appears irreversible, but the laws remain symmetric. Forward works, backward works. Probability decides what we observe. According to Feynman, this statistical behavior creates something profound, the arrow of time. The universe moves from ordered states towards disordered states. Cups break, ink spreads, energy disperses. Everything drifts towards chaos, and time moves forward. But this explanation creates another mystery, an even deeper one. If the universe always moves from order to disorder, then something strange must be true. Long ago, the universe must have been far more ordered, far more structured, far less mixed, because without that original order, time itself would have no direction, and that raises a profound question. According to Feynman, physics still wonders about it today. How did the universe begin, so incredibly ordered?
According to Richard Feynman, the real mystery starts here. Why did the universe begin so incredibly ordered? Because everything today moves opposite. Order becomes disorder. Structure becomes chaos. Energy spreads everywhere. This tendency has a name. Physicists call it entropy. Entropy measures disorder. Low entropy means structure. High entropy means randomness. According to Feynman, nature prefers higher entropy states, always, never the reverse. Consider a simple room, clean and organized, every object arranged, everything perfectly placed. Leave it untouched for weeks. Dust appears slowly. Objects shift slightly. Things become messy. Order disappears gradually. But mess never cleans itself, not naturally. This everyday experience reveals a deep rule, the second law of thermodynamics. According to Feynman, this law explains why time moves forward. Entropy increases, disorder spreads, energy disperses. Yet something curious happens. Even though entropy rises, local order can still appear. Stars form, planets form, life emerges, complex systems grow, but they always pay a price. Order here creates disorder elsewhere. For example, consider Earth. Life thrives here. Forests grow. Animals evolve. Civilizations emerge. But Earth is not isolated. Energy arrives from the sun. Massive energy flows. And while life builds order, the sun loses energy. Heat spreads into space. Overall, entropy still increases. The universe still moves forward. According to Feynman, this balance explains why complexity exists. But the larger rule never breaks. Entropy rises, always. This leads to a strange machine, a famous thought experiment often called the Feynman ratchet. Imagine a tiny wheel attached to a ratchet gear. A small pawl blocks backward motion. The wheel spins freely forward but stops backward motion. Now connect tiny paddles. These paddles sit in gas. Gas molecules collide, random thermal motion. According to Feynman, someone might think this device works forever. Random collisions push the paddles. The wheel rotates forward. The ratchet blocks reverse. So the wheel keeps turning. Endless energy, free power, a perfect machine. But physics says this fails. Why? Because the ratchet also jiggles. The pawl vibrates. Thermal motion affects everything. Sometimes the pawl lifts. Sometimes it slips. Backward motion occurs. Eventually, everything balances. No net rotation. No free energy. The second law survives. Entropy still wins. According to Feynman, nature never allows perpetual motion machines, not even clever ones, not even microscopic ones. Every system eventually relaxes. Energy spreads outward. Order fades slowly. And yet, the biggest puzzle remains. Why did the universe begin with such low entropy? Because without that beginning, time would feel meaningless. Past and future would look identical, but they don't. We remember yesterday. We imagine tomorrow. Memory itself depends on entropy. Recording information creates disorder. So even our minds follow the same rule. According to Feynman, this means the arrow of time comes from initial conditions, not from the laws themselves. The laws of physics are symmetric, time reversible, perfectly balanced. But the universe started differently. It started highly ordered, extremely structured, almost impossibly organized. As time passes, that order dissolves, slowly spreading through space. Stars burn fuel, galaxies evolve, matter disperses, entropy increases, the universe ages. Eventually, far in the future, something remarkable happens. Stars fade away, energy equalizes, temperature balances, structure disappears. Only thin radiation remains. Physicists call this the heat death of the universe. Maximum entropy, no usable energy, no complex structures, no organized motion, just equilibrium. According to Feynman, this ultimate fate reveals something profound. Time exists because the universe is still relaxing, still unwinding, still drifting from its original order toward final disorder. And every event in history, every broken glass, every crashing wave, every spreading drop of ink is part of that cosmic journey. The universe is slowly forgetting its perfect beginning, and that forgetting is what we call time.